In this question, you're asked to integrate sine square x cos square x by sine 5x cos 3x sine square sine 3 cos 2 plus cos 5 whole square. So the denominator looks slightly complicated. So the trick in this question is the simplification of the denominator. So if you see these two terms, if you take sine cube x as common, you get sine square x plus cos square x, which you know as 1. And in these two terms, if you take cos cube x common, you get sine square x plus cos square x, which is again equal to 1. So this is 1, this is 1. So this becomes sine cube x plus cos cube x. So this integral becomes integration of sine square x cos square x dx divided by sine cube x plus cos cube x whole square. Now, once the denominator is simplified, what I do is I'll bring a cos cube outside. So if I take cos cube x common from these two and bring this outside the square, sine square x cos square x dx divided by, so you get cos power 6x outside and 1 plus tan cube x whole square will be left inside. So I am taking a cos cube x outside. So if I do this, so cos power 4x, so this can be written as integration of tan square x times secant square x dx by 1 plus tan cube x whole square. So sine square by cos square. So cos 4 is cos square into cos square. Sine square by cos square is tan square. The remaining cos square, if it goes up, becomes secant square. So now let tan cube x, or let tan x is equal to t. So secant square x dx becomes dt. So this integration becomes t square dt by 1 plus t cube whole square. So now in this, let 1 plus t cube is equal to some s. So this implies 3t square dt is equal to ds. So t square dt becomes 1/3 ds by 1 plus t cube is s, you get s square. So integration of ds by s square is minus 1 by s plus c. So now if you do the back substitution, you get minus 1 by 3 times s is 1 plus t cube and t is tan x. 1 plus tan cube x plus c is the answer. So minus 1 by 3 times 1 plus tan cube x plus c is the answer to this question. Thank you.